So today we will study critical angle. When does this case occurs? Okay. So while the light travels from denser to rarer medium, light bends away from the normal. I have drawn this line. Okay, this is, suppose I have drawn. Okay, this is surface. Above this, if we have here taken denser medium, okay, above surface this is denser medium, and below surface, suppose this is our rarer medium and this is denser medium. So what happens here? Suppose if light bends, suppose if an incident light strikes this surface, okay, this is the incident ray, this is our incident ray. So what happens after, okay, this incident ray if we draw, then we have to draw normal that is perpendicular to this. This is our perpendicular or normal. Okay, this is our normal which makes 90 degree with surface. So this is our normal ray, and the angle between this normal to this incident ray is called I. So whenever these rays incident on the surface, it has to come straight. If there were same medium, it has to come this way, okay, this path. But as this is denser medium, what happens in denser medium? The rays of light, the speed of the light is less than the rarer medium. In rarer medium we have speed of light 3 into 10 to the power 8 meter per second. Okay, but here in speed it is less in denser medium. Okay, it is less. That is, okay, we can say 2 into 10 to the power 8 meter per second. Okay, whenever the speed, this is the not the exact value. Okay, this is just estimate. Okay, because in rarer medium, suppose if we take air, okay, then speed of light is 3 into 10 to the power 8 meter per second. But if we take other glass, okay, because glass in with respect to air, glass is denser. So what is the speed of light? The speed of light is nearly 2 into 10 to the power 8 meter per second. So in this denser medium, the rays of light has less speed, but when it enters the rarer medium, speed increase and it bends away from the normal. So instead of passing this line, it will, this is the away from the normal, it will come here, this is away from the normal, it will bends this is the incident ray, this is the refracted ray, this is the refracted ray which bends away from the normal. So this angle is called angle R. Now as we increase this angle of incidence, what happens? If I increase this angle of incidence here, that means this, then refracted ray also increases. Again we go, and then again this refracted ray increases. Okay, again we increase this refracted ray increases. This is the process here. So I will draw now second line here. Suppose this is our normal. Okay, this is our normal, and if I increase angle of incidence, if I increase angle of incidence, this is increased. If now angle between this is increased, then what happens? Instead of light passing through this path, okay, it will be refracted away from the normal. It means that is in this way, it will not go this, but it will go this way. That means when increase angle of incidence, angle of refraction also increases. and this is our refracted ray, and this is our incident ray. Okay, this is our incident ray. Now if I again further increase this incident angle, okay, then what happens? One condition comes, okay, that if suppose this is our normal, okay, suppose this is our normal, one condition comes that as we go on increasing this incident angle, okay, what happens? This refracted ray moves or bends away from the normal, and one case what happens, it passes through this surface, okay, this passes through this surface. So whenever these conditions occurs, okay, that is called a critical angle. That means if I go on increasing this my incident angle, suppose there is suppose this is 20 degree and this is my 25 degree. What happens if I go on increasing this angle of refraction also increases. Now if this is now suppose this is my 35 degree and this is my angle of incidence is 20 degree. Now after 35 degree, suppose I increase at certain point, what happens? Suppose this is my 42 degree, okay, suppose this is my incident angle is now at 42 degree, angle is got, suppose this is I is equal to 42 degree. This is the case what in case of this happens in the case of what, glass. Okay, in glass critical angle is 42 degree, okay, and in glass 42 degree critical angle, and this is just we have taken an example, okay, 42 degree, it can be anything. What is the major points here? That suppose there is one conditions that when the angle of incidence in the denser medium is goes on increasing, what happens? At certain point the angle, this light, it should pass in this way, but instead of passing this, as it bends away from the normal, what happens? At one condition the light will not come this way, this will not come this side, it will pass through this surface, okay. So this is our refracted ray, okay, and at this time our angle of refraction, okay, at this time our angle of refraction from the normal is 90 degree. So here R is equal to what, 90 degree. In these conditions this I is equal to critical angle, okay, in this case I is equal to what? So there is one definition, okay, critical angle is the angle made by the incident ray. Critical angle, this is the critical angle is the angle made by this incident ray in the denser medium. This is what, denser medium, this is my denser medium, okay, in the denser medium, for which the corresponding angle of refraction in the rarer medium, corresponding angle of refraction, this is what we can say, this or this, okay, this becomes what, 90 degree. So this is called, at this case I is what, I is called what, critical angle. So for different materials different critical angles are there. For water critical angle is 49 degree. For ice critical angle is 50 degree. For glass critical angle is 42 degree. We have supposed this critical angle is 42 degree, then what happens? At angle of 42 degree, what happens? This rays passes through the surface, making an angle 90 degree. So this is in case of our glass, and suppose this was our water. Suppose this was our water and this was our other medium, some rarer medium, okay, here we can suppose here. Then when this angle was 49 degree, then at that time this was the refracted ray passing through this surface, and that time it would be 90 degree, but here suppose it is less than 49 degrees, then what will happen? It will be inside this inside this, it will be what, on the opposite side. That means it is on the opposite side, means it will be inside this radar medium only. And as it angle of incidence is increase, it shifts away from the normal, this away from the normal, and at certain point what happens, at critical point what happens, it passes through this refracted ray. Okay, so this is the case. One more I will draw here. Now suppose this is our denser medium, okay, denser medium, and this is our rarer medium. What will happen here, if I take here example of water, suppose this is my water. So what is its critical angle? Its critical angle is 49 degree. So if this is my normal, okay, this is the condition that when angle of incidence is equal to critical angle. But what happens if this our angle of incidence is greater than critical angle? What happens? Total internal reflection takes place. Suppose this is my two case I have to draw here, okay. Okay, this is my normal. Suppose in case of water, this is my 49 degree, that means incident angle, okay, angle of incidence is equal to critical angle is equal to 49 degree. What happens, this rays will pass through this surface. So this is my refracted rays. And if I increase this, suppose if it is greater than 49 degrees, suppose it is now 50 degree, suppose I increase this angle, this is now 50 degree. If my angle of incidence, okay, is greater than this critical angle, that is 49 degree, okay, then what happens, it will not, this is my denser medium, this is my rarer medium. Denser medium we have suppose here what, water. Then it will, in this case what happens, it will reflect in this same medium, it will not come to this rarer medium, it will reflect to what, same medium at an, okay, with angle equal to this is 49 degree. So it will reflect in this side, and this angle with the normal will be also 49 degrees. So refracted angle is equal to what here, this is now not reflection, okay, this is not now refraction, it is now reflection, okay. In this case up to less than critical angle or equal to critical angle, refraction occurs. But when angle is greater than the critical angle, when angle of incidence is greater than critical angle, total internal reflection takes place. That means totally light, this rays of light will totally be reflected. And in this case, okay, during what happens, during the reflection what happens, some percentage of the light is absorbed by this surface, okay. But in case of total internal reflections, 100%, okay, 100% of the rays of light is reflected. So in this case, when angle of incidence is greater than critical angle, what happens, suppose our here angle of incidence is 49 degree, that is greater than critical angle, our light is reflected and this is totally reflected. So this is our total, and it is inside the same medium, that is it is suppose this is our denser medium, then in denser medium only it will be reflected. So this is internally inside, so it is internal. So this is called what, total internal reflections, total internal reflection. I will provide you some definitions regarding these notes, okay. So you can check my channel regularly so that you can get updates about my uploaded videos. So I will provide you notes regarding this. I will provide you critical angles, angle of incidence, and all the required definitions regarding this. So hope you understand. If you have any doubts, you can comment below. I will try to reply, okay, if I get time. Take care, bye.